Next week, I am going to be a little busy with some other professional work for which I volunteer. As university faculty, I need to be volunteering for other things like university committees and things related to the profession. So I do volunteer for an organization called ABET, Accreditation Board for Engineering and Technology. Let me just show you something. It is good general knowledge. It's related to the profession. So let me show you that and to tell you what it means to us in this class. Let me show you that. What? Okay. 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 This is the website for ABET, abet.org. This is the premier accreditation organization for engineering and computing fields. Not a single engineering program in the United States can be graduating students without it being approved by ABET. There is no such requirement for computer science, but it is considered prestigious to have ABET accreditation. And I have been volunteering for ABET for how many? 14, 15 years, or maybe 12, 13. I don't quite remember exactly. And I am a commissioner. I am on the Computing Accreditation Commission, and I lead teams to computing programs, computer science, information technology, computer information systems, and so on, to universities every year. And we look at programs when we see whether they should be accredited, whether they meet the quality requirements that ABET demands. It's the world's largest organization for accreditation. And this year I'm going on 2 visits. One is next week. I cannot tell which university it is. I'm not allowed to say. And so the issue is I'll be very busy next week with meetings with university officials throughout Sunday, Monday, Tuesday, and possibly, and definitely Thursday, but not, I mean, Wednesday is iffy. If you cannot meet people on the other days, then we will meet on Wednesdays if there is some other conflict. Of course, normally it would have been a face-to-face site visit, but that is not the case this year because of the pandemic. So I am actually doing virtual visits, but still there are lots and lots of meetings. So what it means is that I will have very little office hours next week, but I will definitely answer your questions by email. And there is a chance that I may not be able to hold class for an extended period because of meetings with my teammates and university officials, because it's in a different time zone. So I can't tell where it is. So I may have meetings at all odd hours, sometimes in the middle of the night and all that. So I will try to hold the class for about an hour if possible, and then just let you finish the class exercise next week on your own after going over the initial set of questions with you. I'll try my best to stay as long as possible, but I cannot promise. And I'm going to, at this point, cancel all my office hours for next week, except Thursday afternoon. Okay, I think my work will be done by noon on Thursday. I'm hoping, I'm thinking, that is the plan at least. But I will try to be as prompt as possible by email, but there could be times when I'm just inundated with work, university work as well as ABET work. So that is going to be next week. And it is going to happen again in November because I have another visit coming up, and we will see what happens at that point. I don't have the schedule yet for the November visit. So it is basically the class exercise. In case we don't get time to talk about it, the exam is, today is the third meeting, and the exam is in the fifth meeting, week after next. And it's going to have 2 or 3 programming questions and a number of multiple choice, true, false, multi-select questions, those kinds of things, roughly 50 points. And I will post a sheet that talks about the exam. I mean, you can kind of imagine it is like the subject matter in the first 4 weeks, whatever we covered in weeks 1, 2, 3, and 4. And the multiple choice questions would be roughly in the same kind of the same nature as what you had in the class exercises and quizzes you took before coming to class. It will be roughly the same type of questions. And the programming questions, for that, the best way to prepare is know your material. I mean, that's all I can really say. There could be questions on inheritance and certainly polymorphism, dynamic binding, and all that stuff. So things that we cover the first 4 weeks. And remember that we have fairly new topics coming up next week. Even today, I mean, today, some of the topics you wouldn't have seen before, but next week, it's almost certain that most of the topics you haven't seen before. Still, there will be some stuff that you have seen, like iterators that you will see next week, all right? So that is the rough plan. Any questions before we talk a little bit about the subject matter for this week? Anybody?
Somebody's raised their hand.
I'm sorry?
I got a few questions. It was me, raised the hand.
Okay.
So on the multiple choice, like in class exercises, you also had programming questions. So would those be still available in addition to the programming question for the test?
No, the multiple choice part in the, I mean, it would mostly be choosing A, B, one of A, B, C, D kind of things, or maybe choosing multiple things out of A, B, C, D, E, F kind of stuff. There might be some questions where you have to write, you have to type in some words like what you had last week with dynamic binding and all that, right? You have to write the name of the class or some such thing. So there could be questions like that, but not the kind of programming questions that you had in some of these class exercises, and you are going to have that tonight as well. But the programming questions would be done in Eclipse, and it should be submitted as Eclipse project. There will not be, say, a 10-line programming question in the multiple choice section part. I hope I have answered your question. Is that right?
Yep. And so on the programming side, then you said 2 to 3 programs. Now, would that test be separated, like separate time for programming and separate time for multiple choice, or?
No. I will give you all the questions right at the beginning. Then you distribute your time. I have had that that kind of format for the last 2 semesters, and some mistakes students made was they focused heavily on the multiple choice. I think some of them were kind of testing out programs to see whether their answers were correct. It is entirely up to you to decide how you want to approach the questions. And some of those students ended up with almost very little time to do the programming questions, and they lost substantially on that program, on those programming questions. So I wouldn't, if I were in your shoes, I wouldn't take that approach. I would probably read all the program, read the 2 or 3 programming questions well, have it at the back of my mind, and finish the multiple choice questions more quickly than many students did the last 2 semesters. That would give me enough time to write the programs, or maybe even write the programs to some extent and then go and do multiple choice, come back and finish the programming questions. Because I think, in my opinion, that is entirely my opinion, you cannot blame me for adopting this strategy and losing points. My opinion is that you cannot just spend time on one section of the test at the expense of the other. You are probably better off doing well on everything rather than trying to be perfect in one section and then completely crashing the other one. That is my philosophy, my approach to.
Okay, so how many multiple type questions and how much time allocated for the total test?
The total test would be for 3 hours and 10 minutes or so, roughly 3. I mean, I think we need to probably get some basics done in the first 5-10 minutes. So you'll start the test around 6:10 and make it available till 9:10. And then we'll give 10 more minutes, but with some penalty for late submission. So it is basically, the test is for 3 hours, but then I will extend it for 10 more minutes just to just so that you can do some last minute touches. The reason I do it is this: if I make it due at 9:20, some students try to go to the very last minute, and then they just don't submit by 9:20. Then they have to be penalized for not submitting the exam. Instead, if the exam is due at 9:10, most students submit it by 9:10, and then they don't get penalized. So it avoids a lot of unpleasant situations. So it is 3 hours and maybe 10 minutes more with some late penalty, which I will talk about. You may lose like 1 point for every minute that it is late.
Okay, and how many multiple choice? I'm sorry, I
forgot. Yeah, sorry, I forgot about it. Roughly 25, but it may be a little, maybe fewer questions if there is multi-select questions, which may carry more credit.
Okay.
So not more than 25.
And on the programming side, would you have any point deductions for documentation?
No, no documentation is required, but you have to format your code.
Okay.
Because I should be able to read the code, but I don't need any documentation whatsoever, except I would hope that you would write your name so that I have double confirmation as to who submitted what. Okay. That's the only thing I need. Even that, I'm not going to penalize you, but it would be helpful. That's all. Yeah.
Okay.
Yeah.
Thank you.
Yeah. Any other questions?
Yeah, Professor, on the class exercise last 2 weeks ago, we had to type some answers in the answer box, and there was the issue with lowercase and uppercase. As in, we typed lowercase okay, and the computer took it as wrong answer. Is that going to be?
If it is the name of a class, for example, then you have to type in the correct case. If it is a keyword, you have to type in the correct case. So if the case is incorrect, you lose points.
This was just like typing a simple okay. That's all it was. It wasn't even.
That is a different matter. That is a different matter. But I will give you credit. But I would hope that you would type in as indicated in the question, so that we don't have to spend time on it, on those kinds of things later. If it is okay, I would hope that you, I mean, and if I write capital O, capital K in my instructions, I would hope that you would write capital O, capital K. Otherwise, I have to provide a regular expression or 4 different answers, potential answers for each question, which is a pain in the neck. Like O, lowercase o, lowercase k, capital O, capital K, or some people put periods in between. So there is no end to those kinds of things. It is better if everybody would just follow the instructions as given in the questions. But I will give you, I mean, credit, but it is a lot of extra time for me. I mean, for very little, not for a very valid reason. That's my point. Yeah, but I wouldn't penalize you for writing lowercase okay when I wanted uppercase okay.
Professor, I have another question on the future in-class exercise that you have, and since you're going to have a limited availability, would you allow additional time?
Oh, for next week? Yeah, definitely. Yes.
Okay.
Yeah, I will definitely make it. Let's do it this way. Okay. If I'm not able to hold class at all because of whatever happens next week, I will make it available, say around 4 o'clock in the afternoon. I don't know everybody's schedule, and make it available for 24 hours or so. Okay. If I'm able to hold class, I will make it available at 6 as usual. And then I'll have to close the Zoom meeting at 7, but then you could probably meet among yourselves by scheduling Zoom meetings. But again, I will make it available for an extended period of time.
Okay.
Yeah.
Thank you.
Yep. Any other questions? Okay. If there are no more questions, I will go to the PowerPoint slides, talk a little bit about certain aspects of this week's material, and then we will do the class exercise. All right. The first thing is serialization. Okay. What is serialization? The idea is that you want to store objects perhaps on disk, or you want to ship objects across a network, or transfer from one part of the program into another part of some other program or whatever, right? So what you do is take an object, which could be a collection of objects, so doesn't matter. This could be an array list, it could be a linked list, it could be a tree, it could be just a very simple object for a right. And then you need to get a serial representation of it. If you think about objects, they are pretty complicated. They have fields, they have constructors, methods, and so on, and they refer to other objects. It's pretty complicated, the structure of an object. So getting a linear representation of it as a sequence of bits is extremely challenging. And you need that when you want to store it. You need that when you want to transmit it on a communication line to another machine. That process is called serialization in Java. Okay. Then actually in this course, we are using serialization almost exclusively for storing objects on disk. That is what we are using it for. As I said, it can also be used for shipping it on a network, right? So how do you control stuff on disk from your Java program. So if this is disk and you have a file that represents an object, or if you have basically a file, then you manipulate it through an object in your program. So for this file to be able to read or write or update or whatever, you create a corresponding object in memory. And as you perform operations on this object, the file gets modified or read or written or whatever. That is the essential plan. So for every file that you want to manipulate, you need a corresponding object. That is the first thing you have to remember. That is very conceptual. We haven't gotten into any details. So to create or to store objects that you have in your program, like the first program, you had a rectangle object. If you wanted to store that rectangle object, or if you wanted to store some of the things that you might be creating, I don't know, maybe you are not creating anything specific in the second assignment. If you created something and if you wanted to store, what you would do is follow 2 steps like this. You create, I mean, this there is more than one way of doing things in programming, right? But this is one way of doing it. You create a file output stream and give the name of a file. So from this, you can see that you are actually creating a file on disk. That is the plan. So a new file output stream with a name creates a file, and you can see this word output, which means you're actually creating. And I store that reference in file. So this file controls this file object controls the file some data that gets created on disk. If you don't specify any directory, it creates it on the current directory. After that, what you want to do is treat it like an object. If you want to treat it like an object, you should do an extra step, because this is simply a file. Now you want to treat it like an object. You take this file and pass it to an object output stream. And let me say the reference is output. Then using output, you can actually manipulate this file like you do with an object. For example, this is very elementary stuff. If you want to write some integers and characters and booleans and doubles, etc., you would do these kinds of things. This is not very interesting, I know. I mean, this is not what we want to do, but this is just getting our feet wet. And if you close output, the whole thing is closed. Whatever you wrote in to output would be there on disk. So you wrote an integer, a character, a boolean, and a double, and they had these values. You can read all those back by using file input stream and object input stream. So we are doing the reverse. Previously, we had some data created. Now we are reading, or rather setting a file object in our program to refer to that file we created already. So we use file input stream and feed that file to the constructor of object input stream. That reference is input, and I use input to read the integer, character, boolean, and double. If you see this, I wrote an integer first, then a character, then a boolean, and then a double. So I need to do the same sequence. Integer, because integer is the first thing that you wrote. So integer is the first thing you should read, because integer comes before character, which comes before boolean, and double comes last. So I need to read in this order. I can get all the data back. But as I said, this may not be terribly interesting, but that is something, at least. What we really want is to store objects like this. Television equals new television. account equals new account. So I would like to store televisions and accounts and students and faculty and staff and books and all that stuff. If you want to do that, you do something very similar. So what we learned is not wasted. You would write file output stream equals new file output stream and give a name. You can give whatever name you wish. And I created again an object output stream. No difference from the previous one. Television is an object. So I would write output.write object television, output.write object account. And I can read those back by using file input stream and an object input stream, exactly like what we had before. And I would write input.read object, and I will get a television back. Input.read object, I would get an account back. But what is missing here is a cast. I need to cast. Input.read object always gives you an object back. So I need to cast it as a television. Here I need to cast it as an account. Those casts are missing here. You must put those in.
So can I ask a quick question?
Yes, please.
What's the use case of this? I mean, is it trying to store the state of user session?
Correct.
Okay.
Yes. We will, I will give you a little more heads up. In our first project, we are going to work on a very simple library system. And the library will have members and books and checkout information, everything, right? And we want to store all of that information onto disk, right? So maybe at 5 o'clock in the evening or 10 o'clock in the evening, when the library closes, we want to store all the library information onto disk. So we will do this kind of stuff to write out all the objects.
Okay, thank you.
Yeah. And if you think about it, as I said before, these are not easy things to do on our own. You know, you'll have to spend a lot of effort if you wanted to store objects on your own. Because you see the difficulty here, you're creating a television object, which is complicated. You are right. Even if you store on disk, when you get it back, how do you reconstruct the object in memory? You are seeing a sequence of bits. How do you know, okay, the first so many characters are this type, a string. The next few characters are an integer. How do you know all that? It's a lot of detail, a lot of complicated, messy programming. And Java does all that for us simply by saying input.read object and casting it to your television. It's amazing. The amount of, the simplicity that the whole thing gives us, you know. To give you some more idea, it is all there in the lecture notes, I think. If you had two staff members into a business, both working for the same office, like the business office or whatever. So I have two staff members, very simple example. Tom and Harry are both working for the business office, and my staff member class has a name like Tom, a phone number for Tom, and the department. So it is a reference to the department, which is business office. Yeah, and staff member, actually this should have been two, it doesn't matter. The name is Harry, and he also works for the same business office. If you were to write it out yourself, if we were doing the programming, you can see the issues. If this is object V1 and this is V2, staff member 1 is V1, that is Tom is V1, Harry is V2, and business office is V3. If you write out V1, you have to write out V3, right? So that V1 points to V3. If you write out V2, you have to write out V3 again, but you already have written out V3. So you need to recognize that you should write v3 only once. So if we were to do it in a naive fashion, you would get something like this. But what we really want is something like this. So Java helps avoid all this messy construction. You can really do it in a much simpler way. So that is where the Java serialization mechanism comes in. What you need to do is, I mean, in most situations, is do very simple things. Actually, I don't have the example here, so I need to. I think I probably will use the whiteboard. I'm not going to write extensive code, but I will show you the idea. If you had a class called television, or maybe let's go with the staff member itself. So that's probably better. Staff member. And I'm not going to write too much code. Private string name, private department, and you can have as many other fields and methods, everything here, but that is not important. To write this out, suppose we create a number of staff members, staff member S1, S2, S3, etc. And suppose we had a list. Oops. What's going on here? I don't understand. It's acting up. Let me try. Okay. List. My list equals new array list. Like this. And I put into my list dot add S1, my list dot add S2, etc., etc. Right. So you understand the overall idea. I have a staff member class, name and department, and if you want social security number, ID, phone number, you can put all that. Then suppose we created a bunch of objects. I haven't shown the creations here, but let's assume we have references S1, S2, and S3, and so on. And we created objects of type staff member, put them into S1, S2, S3, etc. I create a list of staff members, and I add each of these objects into this list. So my list would be basically all the staff members, S1, S2, S3, S4, however number of staff members you have. Let's say we have 4. Okay. All right. Now, if you want to dump all these staff members to disk, you can do it very simply like this. You'll be amazed how easy it is. Okay, what you need to do is, no, I need to erase this. What you have to do is something extremely simple. You write implements serializable. Okay. What it means is that obviously you're implementing an interface. This has to be an interface. But the nice thing is this interface has no methods in it. So you don't have to do anything further. Zero methods. All it tells Java is that staff member has to be serialized. Or rather, you might ask it to be serialized at some point. So it is just a marker that says staff member is a class that probably should be, that might be serialized. It is qualified to be serialized, qualified to be easily put on disk or shipped on a network or that kind of stuff. Let me erase all maybe not. One thing.
A quick question. So if there's no implementation, then I guess, what does it really bring to the table by saying implement serializable?
What it means is, as I said, it is simply a way for you to communicate to Java that this has to be put on disk. Normally, if you have the normal situation, there is nothing you need to do further except make department also serializable. But what will happen is from time to time, you might have a class that is not serializable. Then you will have to do some extra work. So this is the easy case. When you should always make it implement serializable, and most of the time you will have to do nothing further. So the point of making it serializable is so that we have a uniform way of treating all the classes that need to be, in our case, stored on disk. So if you want to if you have to put this on disk, this is by default serializable. Java has ensured that string is serializable, but department is our class. So this has to be serialized by us. So what we do is
we just have to implement serializable in the department as well.
Correct.
Okay.
So you need to, you have to have public class staff member. I'm only going to write the skeletons here because I need more space. And a lot of stuff here. And public class department implements.
What if you have anything static in there?
I'll tell. Yeah, we'll talk about static fields in a minute. So I have staff member and department both implement serializable, and what we will do is, of course, we said that there is going to be a list like my list, an array list which contains all the staff members, right? So we assume the existence of an array list here called my list. So all you need to do is go through that exercise: file output stream, object output stream, and let's call it OOS, object output stream. I just want to abbreviate things here so that I don't have to write a lot in this restricted space. So I have OOS standing for an object output stream. And all I need to do is simply do this OOS dot write object my list. This works like magic. I'm invoking the write object method on OOS. And what I am passing is my list, which is an array list. array list has been made serializable by Java. Array list contains staff member objects. Each staff member object is serializable because we said so. And staff member contains department, and the department is serializable because we said so. So what this will do is it will serialize my list. I'm sorry, okay, I think I'll have to use, I can't use the pen for a while now. This my list is going to be a sequence of staff members. Java will serialize my list, and in the process, it will dump S1, S2, S3, S4, the associated department, everything onto this object output stream. And if you have connected it to a file output stream, everything will go into disk. And in one line, you would get all of this data returned to disk. So it's amazing. And then you can write OS.read object at a later point to retrieve my list. And from my list, you can retrieve all the staff members and their departments. Now, you asked about static fields. If you have a static field, it doesn't get written out. Okay, so that is Java's design decision. We have to live with it. There must be a reason why they didn't want to write it out. So if you have a static field like ID counter or some such thing, then that doesn't get serialized. Java will skip all that. And if you have any field written as a transient, which we haven't really covered, that won't get written out.
So if you have a staff member like an ID that you're, keeping track of, like, 10 employees and 10 IDs. So when you restore it, how do you, then I guess your ID structure you wouldn't have that, right?
What you're saying is you're assigning numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right?
Yep.
And you get that number from a static field.
Yep. So they're kind of like employee IDs.
Right. So I think your design is like, I will have a static field that initially will be 1. I will use that static field's value to be assigned to the ID field. And then I will increment the static field. Is that right?
Yep.
Okay. Then what you'll have to do is you will have to write out that static field separately at the end.
Okay.
You can do it on your own, but Java will not do it for you.
Okay.
Yeah.
Thank you.
Yeah, good question. So reading back is almost as painless. You might call it object input stream, OIS.read object, and then you cast it as an array list, and then you have an array list of staff members. That's it. There are some complications when you have, as I said, fields that are not serializable. But then you have to worry about them. You'll have to find a way to get that data and write them out. You will have to write extra methods. But usually it is not very difficult. Okay. Any questions? Okay, then I don't think I have anything more significant to add this evening. So we covered serialization was the big one. And then graphical user interfaces we covered briefly last week, and we are not going to spend much more time. You are working on the assignment. As you probably have discovered by now, in Java, there is something called a stage in JavaFX. And in a stage, you can put scene after scene, and the scene can contain things like buttons and all that. So what you would normally do is you will put widgets like buttons and text fields into a container like a horizontal box, H box, or a V box, or a grid pane, and put the grid pane or the V box or the H box into a scene, and the scene goes into a stage. So you can have a number of scenes and one scene at a time on a stage, just like a play. That they designed it like that. So there is a stage which is sitting there, and you can have multiple scenes put into them one after the other. You can have multiple stages also in your Java program. That is the basic idea. And you have to, as you know, you have to have your class extent application. This is the main class. And one thing you have to realize is that there is a single Java FX so-called thread that keeps running. All the graphical user interface work has to be done in that thread. That will be, I mean, it may not make much sense now what I am saying, but it will become important when we get towards the end of the course, okay? So when you run all these code, it is the Java FX thread that does all the work. You can't create a thread of your own and make it do these things. You'll simply get a crash. That is the case with Android also. When you have do phone programming, you have to do everything on a special user interface thread. As I said, don't worry if you don't understand anything, but just be aware that there is some restriction on who can do this graphical user interface work. It will become clearer later in the semester. Okay, so we talked about grid panes, and then you can have columns and rows specified for adding stuff. So create a grid pane, add text fields or buttons in column 0, row 0, column 0, row 1, then put the grid pane into a scene, and then put the scene into a stage. Java, when your program starts, you get a stage for free from Java. Java FX creates a stage and then gives it to us in the start method. After that, you can create your own stages if you wanted, but there is a primary stage that Java gives us. And here is how you would listen to events. You would say, tell a button, when you are clicked, let this object listen to it, whatever this object is. This object, the object that this represents must implement event handler, which means implementing this method, public void handle action event. So when a click is done on this OK button, this method will get called as an event, and then you will check whether it is the OK button or some other button that was clicked, and then do appropriate things. Another example, mouse event. Okay. And finally, UML diagrams. We will see a few types of UML diagrams, but that is not the major emphasis of this course. UML is nothing but documentation, and it is a huge specification. I have tried reading the UML manual. It is extremely painful to read it. It's very difficult to understand. You should try to learn UML in a more painless way. Like we will be, there are 3 types of diagrams: structure diagrams, behavior diagrams, interaction diagrams, and so on. Like we have class diagrams to describe a class, and we will frequently use object diagrams. So these would be the 2 types of structure diagrams we will be worrying about in this class. We might talk a little bit about package diagrams towards the end of this semester. Then we will be spending some time on use case diagrams and state machine diagrams. They show the behavior of the system. And finally, we will also see what are called interaction diagrams. So we will be spending some time on sequence diagrams. So here is an example of a UML class diagram. If you have a class called student and you want to represent it pictorially, this is the way you will do it in UML. You draw a box, divide it into 3 parts, put the name of the class at the top, then put all the fields in the second box. You put minus for private fields, plus for public fields, and a pound sign for, that is the hash symbol for protected fields. And you put the type here, put a colon at the end of the identifier. You put the constructors and methods over here. You put plus again for public, minus for private, pound for protected. You put the parameters like this, the name of the parameter and type, name of the parameter and type. And the type of the method itself, what does it return, is here, like get GPA double. Okay, it's a good question as to what you will do if you had 100 different methods. How do you draw a diagram that has 100 entries for methods? I don't know. Okay, I suppose you will probably not show everything. You probably won't show any getters and setters. You will probably not show toString and all that. You will show maybe a selected number of methods, or maybe you'll split this into multiple diagrams or some such thing, or you will probably have overflows onto succeeding pages. It's very unwieldy to draw this for large classes. Okay, then this is an example of what is called a use case. That is, I think Shahid talked about and mentioned this use case term. That is, you have the interaction between users and the system. So for example, here is one user performing actions with the system, maybe getting some money from an ATM, right? This might be the interaction. You insert the card, then the system asks for the PIN number, etc., etc. So this is simply to say how users should be working with the system. So this is to understand requirements. There is no computer science, I mean, there is no programming here, right? You're simply analyzing a system and then saying how the system should behave to external users so that you can understand their requirements. This captures that. Use cases can have multiple columns and all that. We'll talk about this in more detail in lecture 6. Then, of course, here you have use cases. This is for understanding somebody's requirements. But then how do you actually satisfy those requirements? Then you need to say, well, here is the user, this guy. Now the system is here. At this point, we didn't know what the system is going to be constructed from, but we now are saying there should be an ATM, there should be a bank account, and there should be a collection of accounts. And this is how the ATM will interact with the bank account and accounts. We are having this sequence of interactions. For example, the user inserts the ATM card, the ATM machine asks for the PIN is submitted, ATM machine sends it to the accounts object using a method called get account. So this is probably software, right? You are passing the card number, and then it retrieves the account, and further interactions with the account to debit or verify the PIN, and then debit the account, issue money, give the card back, etc., etc. Again, we will see this many times this semester. Just wanted to show you what it is. So here we have a collection of objects. They are from left to right, horizontally, and time increases as we go down. So sequence diagram shows how to implement a use case. Use case is for analyzing things. When you talk to the user, you write down your points and then construct the use case. Then you go to your office and then see, how am I going to implement this? At this point, you decide there has to be an ATM, there has to be a bank account, there has to be an accounts object. This should be the methods. You are designing things, right? Afterwards, you will program this. So this is design. You are documenting the design. You're coming up with the design, and you need some way of expressing your thoughts. Ultimately, all that has to come from your mind, from your brain. This is simply a way of expressing the stuff. This is simply documentation, nothing more, nothing less. The structure diagrams, one of the things you can do is actually show an interface and then show its implementation. So if you have an interface, you might write interface like this, and you would put your interface name in italics. You will put the methods of the interface here, and you will put the class here, and then show an arrow like this to say that this class is implementing the interface. Then we have relationships between classes. We talked about one-to-many, many-to-many, one-to-one, and so on. Students registering for courses. If you have that in your system, if you have a university system, this might be something that you might have, like students, maybe it should be called sections. In any case, one student can register for many courses, and a single course can be having multiple students. So you put star and star on both sides. It could be 1 star, 1 star 1, and so on. Then genericity, we'll have a few questions this evening. Genericity makes it possible to reuse a class for different types of data. So if you want to have a class of objects, this is what you do, but this is not a very good way of programming, because just about anything can be pushed into the stack. You have seen this in ICS 240, so I'm just glossing over these things. If you really want to make it cater to a specific set of classes, you need to specify that at the time of class creation. So you write public class stack, and then in angle brackets, you put a letter, usually a cap. I mean, you don't, doesn't have to be a single letter, but this is the convention. You put a capital letter like E for entity or whatever. And then you use that in appropriate places. So what we are saying is we are going to have a stack of type E, and we are pushing items of type E. When you pop, you get items of type E. So you can instantiate it like this, stack, and then pass the type you want to store, integer. My stack equals new stack integer. You don't have to supply this particular integer here. You can just close the angle brackets without specifying this. It is understood to be integers. And into my in stack, you can only push integers and its subclasses, if there is any.
Just a quick question. So by convention, so let's say if you wanted to do stack and the bracket employee, can you write that out fully? Employee, it's that according to convention?
Yeah. I mean, here, you mean here?
No, on the right-hand side.
All right. Yeah, of course. Then you have to put the class name. Yes.
Okay.
Yeah.
So that way you know which type of objects it can take.
Oh, you mean stack employee, then my employees or something?
Yep.
Yeah, I would give a name. I mean, here, of course, it has to be the name of the class, but here I would give something that kind of suggests that it is the employees stack.
Okay.
Yeah, I would use my employee stack or some such thing. Yeah.
Okay.
Professor, for
Sorry.
interfaces, yeah, for interfaces, do you recommend us using generics or?
Yeah, it depends. Let me see here. Interface. Yeah, if it is appropriate, yes. Yeah.
Okay.
Yeah. Okay. All right. I'm not going to talk about packages. I mean, most of you have used them to a reasonable extent. Okay. I'm going to stop recording here.